what these are essentially used for is when you have a language that's general purpose and it does everything reasonably well, these domain-specific languages can come in and they can really take the game up a notch in one specific task, right? So for instance, when you're querying XML documents, we'll typically use something called XPAC or XQuery. You'll see this often, right? If I take my my browser right here, just to give you a demonstration, and I do this Control-Shift-J to get back into this mode, and I right-click and I go inspect, you're going to see right here this HTML body article block quote key thing. All of this, you'll figure this out later. You see here. Copy XPath. All of this can be reduced to this language called XPAC, which is a domain-specific language. This gives you the ability to target anything inside of HTML, right, with something that makes it substantially easier than writing the same code in JavaScript. So I can go copy XPath, and then I can go to something like the terminal, right? I'll make it a little bit bigger for you. I'll close some of this other stuff. And we can paste this, and you can see here what we pasted. HTML body, article, block quote 1, right? This is XPath that tells you how to get to that element I was just at with Chrome. Look for the HTML tag, look for the body tag, look for the article tag, look for the block quote, and it's the first element inside of it. That's called XPath, right? That is a domain-specific language. When it comes to querying XML, you'll use this often, or HTML, right? And it's part of a subset of another thing called XQuery. My point here is that JavaScript is great at doing a lot of things, but it's horrible for doing stuff like that, right? Because in JavaScript, you have to say, find me the HTML element, then you have to iterate through all the elements beneath it to get to the body element, and you iterate through all the elements beneath that to find the article element. You have to crawl through this thing called the DOM yourself, and this is a lot easier, right? A lot of people hate regexes, but regexes are domain-specific language for parsing text, just like Jared said. So when you have to parse text, right, you can do it multiple different ways. There's always more than one way to skin the cat. But a regex is a domain-specific language that gives you the ability to parse text, writing a very short amount of code that's very terse and gets the job done. And despite what a lot of people say, when I say a lot of people, when a very vocal minority of people, a regex is a relatively maintainable way to do this, right? It's a lot easier to maintain a regex that's 15 characters than it is to maintain 200 characters of C code. And we're going to look at something in the very end of this chapter, which is actually a pretty good example, which parses an INI file, right? So INI is like configuration files that Microsoft has, and we're gonna parse one of those files with JavaScript regexes. Okay, so how do we think about regexes, right? We had someone asked me a question on Facebook, and they were asking if they had to study up for the class. Is that person here? That's you? Excellent. So, and I said, look, this class stands alone. You don't really have to know the other material that we've covered in the class to get in here today. And the reason for it is simple. This is a domain-specific language. This isn't JavaScript. So you're not going to, it predates JavaScript, regexes. There's nothing about JavaScript that's going to be applicable to today's lesson. We're covering regexes, and you need to think of them as a whole other language. You can buy a book on regexes. It's called Regexes by Damian Conway.
It's called like Mastering Regular Expressions.
There we go. Understanding Regular Expressions. This guy wrote the book on it. What's the O'Reilly book called? Does anyone happen to know it?
Mastering Regular Expressions.
Yeah, like there's actually
that's
a
it.
This is it. There we go.
Yeah, that's it.
Mastering Regular Expressions. You can buy a whole book on just regular expressions that has nothing to do with JavaScript.
With any steps.
Yeah, and look, guys, it's And
it's an awesome
use it
book,
pretty
by
cheap.
the way.
This is actually how I learned regexes. This is a really awesome book because this is going to show you comparative implementations of different regexes. How many people in here use Vim or Emacs or some type of editor? Most of these editors, guys, have regexes built into them. So when you need to search for documents, you can just type the regex that you want and find the text you need. My point here is that it's a totally different thing than JavaScript. It has a totally different set of educational materials. It's only inside of Eloquent JavaScript because it's so damn good at doing what it does that it is one of the domain-specific languages you should learn if you're going to get into JavaScript. Very good at parsing text.
And
So
it's so good at doing what it does. It's not just in JavaScript. Variants of it are in pretty much every major language you'll ever program in. It's really good.
I can't think of too many exceptions. It's already. Okay.
How much of that will carry over?
I would say 90%. So your basic concepts that we're going to go over today in a regex, all of them are going to carry over. Now, look, there are some implementations of regexes that we could have taught that we're not teaching because we're using JavaScript implementation, where I would say that percentage is much lower. Perl does a ton of stuff inside of their regex engine that is not useful or not portable. There we go. That's not portable anywhere else. Super useful, but not portable. In Perl, you can literally write your whole program in regex, and it's terrifying. But there's actually if statements and conditionals inside of Perl regexes. It's a lot of fun. But JavaScript is a lot saner on this. So what essentially happened is, in the 60s, these things emerged. This idea emerged. Parsing text was gigantic. People were going to find out the Bible code and all that kind of crazy stuff. And I guess there's still a bunch of quacks that think they're going to do it. Regexes were enormous. Perl implemented its own version of regexes. Everyone learned Perl because it was so good with their regexes. That when other languages came along that wanted to compete with Perl, everyone said, look, you don't have regexes, we can't use this. A library emerged, it's called Perl Compatible Regular Expressions, PCREs. And they all implement a flavor of the Perl syntax for regular expressions. And today, most languages that say they're using a regular expression are using some form of that PCRE syntax, which is what we're doing today. So these regexes are Perl compatible regular expressions. But Perl as a language does all kinds of crazy stuff with their implementation. Okay, so creating a regular expression, first page. There's two ways we can do it. One of them is the object syntax, which is right up here, new regex, ABC. You should almost never use that syntax. Don't use that syntax, it's stupid. The syntax below, much better. ABC, this is the literal syntax. When you create a string in JavaScript, you don't ever say new string. You can, but it's stupid. Just put your string in quotes, right? For sanity. So we're going to largely ignore the top syntax, and we're going to come on down. This is the bottom syntax right here. This is the first regular expressions we have seen. This is this 18 right here. And let's go over that, right? So a regular expression, if you give it literal characters, right, like this word here, 18, it's going to match anything with 18 in it. Plus is special with a regular expression. Those are called quantifiers, right? And if you have a quantifier like plus, you have to escape it. And that's what he's showing here with this. He's showing you that he's escaping a plus, and that's the only purpose of this. So he's saying match me a string with 18 and then the actual character plus. You must precede it by a backslash if they're meant to represent the character itself. Not a big deal, but just remember if we're using backslash, if we're using pluses or periods, those types of things, in Perl, in JavaScript you need to escape them. So this is one of the methods that we have to make use of regexes in JavaScript, .test. So we can use string.match, which takes a string and it sees whether or not the regular expression provided matches it, or we can use this .test, which takes a regex and it sees whether or not the string provided matches the regex, right? So both of those work. Let's take a look at this right here. So if we take something, right, here on my screen, getting ready, and we say something like hello, hello, and now we're going to use .test, hello, right? Very simple. Hello.text, text. That's not right. Hello.test. right? Like that. That's a direct match. That's not the right way to see whether or not two strings are equal. Robert made a comment earlier on in class. He said that these tools are used often where they shouldn't be used, right? This is a great example of something you shouldn't do. If you want to know whether or not two strings are equal, just test to see whether or not they're equal. But this is showing you that that's the basis of how a regular expression works. Now, what does a regular expression provide that equality doesn't provide, the equal operator doesn't provide, right? There's a lot of things. So if I come up here and I say, hello, Evan, right? That still returns true. If that was an equal sign, that would not return true. This is the kind of thing that you want regular expressions for. This is the shortest way to accomplish this task, right? So I'm trying to see whether or not this string starts with hello. Actually, this string contains hello. Let me be very precise about it. Whether or not this string contains the pattern, which is what we call this, hello. If something is inside of a regular expression, we say that that thing inside of it is the pattern. That's what I'm testing here. I'm trying to find that pattern. Okay, so let's see here. Let's take this, and I want to show one other thing here. So what we're saying here, let's go over this one more time. I'm going to show you this. Look, we have this thing here. Where did it go? Did it just move on me? There it is. Okay. Look, we have this here. This is also not it. A little bit more. There we go. Okay. Here we go. This is the right one. Look. Inside of this, we have all of this stuff. This is what's getting returned in the first one. The capture pattern, these parentheses, this is what's getting returned in the second one. So in the second one, we see just what the parentheses are capturing. I said the parentheses are good for grouping and capturing. That's what this is, right? This over here is the whole thing. It's the whole pattern. That's what that is, right? So this was interesting to me because I don't think maybe this Perl doesn't return this, right? Perl makes you put it in a capture pattern. Perl doesn't return the whole thing matched. Anyway, this is unique to JavaScript, right? This interface is unique to JavaScript. So I was spending a lot of time at the beginning of class trying to figure out why in the crap, when I was matching the parentheses, they were still being returned. And the answer was just precisely what Ed pointed out. He intuited it, right? That this is the whole thing. This is the individual capture patterns. All right, are we not doing pizza today? What's going on? Do we have a plan?
I gotta go and check the email because I don't know what's going on.
Aha, okay. All right.
This is the time, right, when you actually
let's take
cut it and
let's take a break here.
let's take a little break.
Maybe
Funny
they
break.
ran out of pineapples.
They have there, so if we say something like, hello, dot * food, 5, and then I can say something like, that's whatever.
I don't know if we're going to
It'll print it out like this.
I got your number.
Right? It says match the string hello, any character, FO, 0, another O, and then 4 times, and then text. It's telling you how to parse the regex in English. So if you have an idea, you say to yourself, I think I understand how that regex works, and you don't know how that regex works, you can test what you think against how it works with it. All right, so let's finish it off. Okay, we're looking here. We're going to finish off capture patterns. If you put the parentheses around something, it gets returned when you exec, and you can see it right here. So what we're doing here is we take the regex bad, and then we put in parentheses ly, and we exec, and we have bad, and we get nothing. Notice how that's undefined. Can we take that down just a notch of the volume? A notch? I want the feet.
Not yet.
Sorry, I'm installing software on Linux.
I know, but that's not what anyone else here is doing. Okay, so if we do it again here, if we want to see this, we're going to add to it this time, rather add it to the pattern. We're going to add it to the string on the right hand side. And now you can see this time, because we have in parentheses ly and our string has ly, it's actually capturing it. So I'm going to make this bigger and we're going to go over this one more time. And we just finished it off and explained this really well. We have a regex here, we have a string here. The first thing that's returned is the whole regex that we're matching. The second thing that's returned, the ly, is just the stuff in parentheses. That's what we're capturing. That's our capture pattern. All right. So here you can see that they have the regex is essentially one or more digits, right? And then they exec it against 1, 2, 3, right? But here's the thing: the plus is on the outside of the parentheses. Because the plus is on the outside of the parentheses, what we're essentially going to be doing is just capturing the first digit. Right? So we're capturing the first digit here, 3. Actually, this is the last digit. All right? So let's see here.
What is that? The L is the last one.
I can actually tell you why it's the last one. I think a better question is, why aren't the first 2 there? And we don't want to also extract it, because we're not going to represent it.
It explains it in the paragraph above it.
There you go. There's your reason. JavaScript. That's the answer. So we had the question came up earlier, right? How much of this is portable to other languages? This kind of stuff isn't portable to other languages. This is called the API, right? So the API in this is a little funky. The API with exec is that you only return the less match, and that's just simply because JavaScript, right? In other languages, you may return all of the matches with this, right? Or if you gave it a G, you would certainly return all of the matches, you know? And we're going to get to that in a second, which are flags. Moving on. Okay, there is no other answer to that. In JavaScript, if you have the match multiple times, you're only going to see the last one, right? And there are definitely ways around that, which we'll see in a second. Okay. The date class. JavaScript has a standard class for representing dates, or rather points in time. It's called date. Here's how they're using it. They say new date, and essentially it's giving them a string back with the date. Now we're going to try to parse that out with the regex. By the way, you would never do this in production code because there's different methods of doing all of this. You can create an object for a specific time. New date 2009, 11/9. That's year, month, day. And it's returning us back an object with date. All of the time is 0, but the date is there. Right? And what they're saying here is, let's go down. They're just showing you different date constructors. Okay, here we go. Now we're getting to the meat of it. We have this function here called getDate, right? GetDate is going to take a string, and what it's going to do is it's going to, from that string, break out month, day, year. And here's how they're doing it. They have a regex, and the first capture pattern has 2 digits, 1 or 2 digits. The second capture pattern has 1 or 2 digits. The third capture pattern has 4 digits. And they're execing that, they're calling that against the string that you provide. Right? And they're saying, return a new date that's 1 month earlier. So if you give it getDate 1/30/2003, right? What it's going to do is it's going to return a new date. I'm sorry, it's going to return a new date that is the same thing, 1/30/2003. So why are we doing the month minus 1 here? Does anyone want to take a guess at this?
It's the previous month, I guess. It's
Are the month 0
Date
based?
starts at 0 for January.
That's exactly right.
Right?
So the reason is that the 0 month in JavaScript represents January. So the date is 0 based, right? Okay, I'm going to scroll up and we're going to go over one more thing here because I don't want anyone to cheat. If I can, there we go. Okay, that's not working. There we go. The underscore here, right? What does this have in it? Anyone want to take a guess? This is the way JavaScript does it, and I said this is what copied at the beginning of class. The underscore is going to capture everything, right? Because the underscore matches the entire regex. Then we have the capture parentheses. They come in as different variables: month, day, year. This is going to match everything that the regex matches. Okay. And again, we asked the question, why are we subtracting 1 from month? We're subtracting 1 from month because this here, when we give it this 1/30/2003, that 1, right, is what this is going to match. So this variable will be 1. But when you want to create a date with new date, right, you need to provide it 0 for January. Marco picked up on that. So the months are 0 based in the construction, but they're 1 based for English because we don't ever say we're in the 0 month. Okay. So we have here the string cat. We're testing against concatenate. This is just more testing stuff, and we've already seen this. So. Here's what they're doing here. This B, this is what they're introducing now. B is called a boundary match. So we saw these earlier, right? Which one of these / things have we seen? Someone name a couple of them. We saw.
Escape.
We saw this for what? Digit, exactly. Thank you. Digit is D, right? We also saw this for spaces. Spaces is. We said we could negate all of these simply by capitalizing it, right? Anything that's not a space, capital S. Anything that's not a digit, capital V. Now we're seeing another one, B. B is interesting because B doesn't match any character. B matches what they call a boundary character. It sits in between a word character and a non-word character. That's what B matches. But it doesn't capture a word character or a non-word character. Right? So they're saying here, match cat is a word. And here's the catch. Up here, when we matched cat, we picked it out of this in the middle. So that was returning true. But because we put the boundary characters in here, right? Now when we do it, we return false. Now there's some other things we talked. These are actually called anchors, right? So there's 2 other anchors that are very important, and I don't know that we've covered them yet. Yeah. We'll get to them later. Okay. Choice patterns. Okay, so we talked about parentheses being used for grouping things, right? In this parenthesis, we're matching pig or cow or chicken. So we're introduced to a new character. Remember the question mark at the end? That means 0 or 1. So we can have that be plural or not. So match 15 pig chickens, that's false. Why is it false? Because we have a pig here or a chicken. You don't have a pig chicken. Right? So this is a very, very small mechanism for writing that. Boundary character means we're not going to accept a 5. We have to have 5 by itself. 5 space pig, cow, or chicken. It can be plural or not. And then another boundary character to stop that. Okay. The catch here is that we're using parentheses now with or, right? So now they're introducing this tool, and this tool is going to help you make sense out of a regex. You get something that's really crazy, and you can pop it into that tool, and that tool is this regex thing here, regexer. And what it's going to do is tell you boundary, 1 or more digits, and then a quote character. I guess is how you read that.
I think that was an attempt to show white space, but you cannot see the white space between the quotes.
That's it. He's got it right. That's exactly right. Thank you for that one, because I had no idea. I don't really like these graphs anymore.
Good.
So that's exactly right. Boundary, digit, 1 or more digits. That's why there's a little loop underneath it. And then a white space, right, character. Then we have a pig, cow, or chicken. This is the group. Then it can have an S or a boundary character. See the line going through the S? That means it has an S. The line going around the S, that means it doesn't have an S. Both of those paths are viable with this. That's how they're showing it. Just to be clear, if the line goes through it, you have it. If the line is going around it, you can keep going infinitely, right? That's because there's no upper bound, so it'll match an infinite stream of digits. So that's a loop, and that's what they're showing you there. They're showing you that loop keeps matching your digits. This here, pig, cow, or chicken, there is no loop. When pig is done, you're at the other side of it, and you're connecting again, right? Same thing with cow and chicken. There's only one way out. Okay. Does anyone have any questions? Are we getting this?
Yeah.
Okay, cool. Okay, backtracking. This is fun. Now we're going to be talking about greediness and all that other kind of stuff. If you look here, the character 0 or 1 plus, meaning one or more of them. B, this is a really, really horrible example. What are they doing? I'm sorry, that is really stupid.
That's an attempt to match a string representing a hexadecimal number.
I know, it's going to take me all week to say. And look how stupid that reads in English. Look, matches the 0 or 1 or more times with a B. Or, I mean, that just sounds weird. They're matching, is what they're trying to do is they're matching a hex number, right? Something that's base 16. Anyone know what a hexadecimal number even is? Yeah. Half the people know. What is the highest letter on a hexadecimal number? F, right? So essentially, in English, in the wonderful land of freedom in America, we have 10 characters that represent digits, 0 through 9. That's because we're a decimal-based numbering system. Even though we have totally screwed up because everyone is stupid, the metric system is very right on this, right? Metric system is base 10 numbering system and base 10 measurement system. English is a base 10 numbering system and a crazy wackadoo measuring system, where it's based on like the size of, you know, king's body parts and crazy stuff. But the point here is that when we look at the computers, we do computer programming, we don't use base 10, right? Not everyone uses base 10. Computers use base 16. There's a lot of really good reasons for that, and we've done classes on that, and a lot of us like to teach it, but it's low-level stuff, and you don't see it much in JavaScript. So a computer, when it gets to 10, 0 through 9, that's its 10th number is 9, it keeps going. Then it goes A, B, C, D, E, F, and then it goes back to 0. Right? That's how the first digit of a computer notation would show in hexadecimal. Right? Now that's really, really baloney because of course the computer is just binary. But when we show this stuff, this is how we do it. We do it with hexadecimal. So now that we know what this hex thing is, this is the graph to make it. I think this is a really horrible way to do it. I'm going to show you a different way to do this. Look, we're going to explain this with something a lot simpler. If we do this, foo. Okay, let me give a string, foo foo, right? Let A equals foo foo. Oh, I already have it. There we go. A equals foo foo. Okay. Now, if I want to, okay, let's do this. Let's add one more in there. Foo foo foo. There we go. We have 3 foos in there. If I want to match, just foo, right? We can do A dot. And by the way, remember the tab matching our tab? There we go. So I'm going to do here foo. You can see here that we're matching 1 foo, right? If I do asterisk, I match. That's a really horrible way to show this. Hold on there 1 second. I want to see where this thing is going. What do you think is the easiest way to show greediness, Ed? The easiest way to show greediness.
Greediness?
Yeah.
Do a capture group that is trailing with a character, and then capture that character into a second capture group is the first thing. First group is BA plus, and the second group is AB.
BA plus?
Yeah, the second group is AB.
Are these strings or patterns?
Patterns.
I'm not following you. I'm trying to think of a new way to show this because this is a mess.
So, what I'm talking about is something like this.
What thing is that?
And you can adjust the greediness to show which aids fall into which one.
Yeah.
Okay.
You make it this one
Have
greedy,
some
it
favorite
expands
fruit
out,
beans?
captures all the aids except for one. You make this one.
Not really. I tried most of them.
Ah, you mean together?
Mm-hmm.
Yeah.
Okay. Yeah.
Okay.
Okay. That's actually a really good idea. That's a way to go on this. Okay. So here we're gonna have a string and we're gonna say B like this.
Bob.
There we go. And now we can do string dot match.
Well, you need a plus in the last one, otherwise it'll only match one and it won't matter about the
There we go.
on the A.
I'm trying to figure out where this
On the A.
coming from.
Yeah.
Okay. So here's what we're doing. When it comes to showing greediness, I think that this is a much better method of doing it than the next idea. If we have a string here, which is essentially we created this string with all of these A's in it,
Yeah.
right? We have two patterns. We have BA, and then we have another pattern, AB, right? We want to know which one of these two patterns is going to get the A's from the string bad at the very top,
The bulk of the A's.
right? Both of the A's.
Bulk.
Both.
Dude, you're a guy.
It's actually 4 A's. Bulk of the A's. Which one of these two strings is going to get the bulk of the A's? We can determine that by qualifying the greediness, right? So how this is currently parsed in JavaScript is we have B and then one or more A's. Because the plus is what we say to be greedy, it's going to gobble up the entirety of all of the A's. All of the A's are going to go to the first pattern, and then it's going to slowly give them back to see if it can match the second pattern. Right? Now the second pattern requires one or more A's. Right? So the second to second pattern gets what it needs, that one A, it's done. So the first pattern is going to say B, A, and then all of the A's. And then the second pattern is A, B, but we can't match that because we have a B. We don't have any A's. So we're going to give one A in backtracking, that's what we call that. And it's going to say, okay, now do you match? Now you have an A and a B left. And the second pattern says, yeah, I match. And then it's done. This process of backtracking and not backtracking is what determines greediness, right? So if you want to simply say, make the first pattern not greedy, all you have to do is add a question mark at the end, like that. And there you go. Now it's not greedy, right? Now before, if you look up at the top, the first pattern got the bulk of the A's, all of the A's. The second time we did it, when we made the first pattern not greedy, the first pattern only got one A. Why? Because now it's not gobbling up all of the A's. Now it's saying, give me a B and an A, right? It gets its B and its A, and then it tests the condition right away, right? It says, am I done? Now the plus means one or more, so you're done. So if you make the pattern non-greedy, then it's going to work the other way. It's not going to gobble up all the A's and slowly give them back. It's going to gobble up one of the A's, test the other pattern. Then if the other pattern passes, it's done. If not, it would gobble up another A and then test the other pattern. That's how regex works. They're either going to gobble up all of the A's and then slowly give them back to see if the other pattern passes. And when the second the other pattern passes, it's done. Or it's going to gobble up the A's incrementally until the other pattern passes. As a programmer, you know the other pattern is going to pass right away. So if you're non-greedy here with the question mark, then it's done. The first pattern is done right away, and the second pattern is done right away. You've saved the computer the work of having to do any backtracking. All right, Marco. And I know, by the way, guys, I know that's crazy complex, and you're going to have to see that a lot to make sense out of it, and you're not going to be using it all the time. You'll use regexes all the time, but you won't use the greedy qualifiers all the time. So you'll learn them slowly and surely. Yeah?
Maybe it's just another way of saying it, but so if you have two greedy searches next to each other, one on the left and one on the right, the one on the left is going to get, it's going to be greedy and going to be as greedy as it possibly can. The one on the right is only going to be greedy enough to get its minimum requirements, and that's because it's reading left to right.
If you make the leftmost pattern non-greedy.
No, but in your first example, they were both greedy.
Say it one more time.
In the first example, they were both greedy.
That's right.
So you have two equally greedy searches, one on the left, one on the right next to each other.
Right.
And it looks like the one on the left won.
That's exactly right. The one on the left runs first.
Okay.
Yeah.
So it's order of time. Whichever one runs first. And in this case, it's the one on the left has to run first.
So the one on the left
always
is going to be as greedy as it possibly can. The only time that it'll give away things is if it's absolutely required to make the rest of the pattern match. And it goes from left to right precedence. So basically, if you had 5 of them, each one of them would grab as much as possible until they had to give up something to allow the whole pattern to match. Because like if that one on the left took all the A's, then AB couldn't match at the end. So it has to give back one of them. And as soon as it gives back one of them and AB says, well, you know, I can deal with that, then it's done. But if you make it non-greedy, then as soon as it's satisfied, the rest of the characters go into that other portion of the regex, and if that can't match, then it'll go back to the first pattern and say, okay, gobble up another one, and keep doing that. So it's just a matter of deciding which way is faster, and if you happen to know the inputs that you are likely to have, you can decide which way is faster or which one matches your groupings.
I'm guessing the second plus is actually unnecessary. Would it come up with the same results?
If I don't put the second plus, then for the greedy match, absolutely, it'll be exactly the same. But if I put the second, if I don't have the second plus, then we can't compare and contrast the two because there would be no chance for
Right.
error.
This is just trying to show without us having to actually parse text.
So it's a contrived example.
Yeah,
Yeah.
it's a contrived but good example.
Yeah.
Okay, guys, look, we're going to do this last thing, then we're going to get out of here. So this last thing is this parsing INI thing. I'm going to go over this, and we're going to see if we can all understand it. I don't think most of this stuff they're getting into. Regexes are a very deep subject. There's literally 400-page books on them. You shouldn't cry if you miss one page of this, because there's a ton of stuff that they can do, especially in other languages. So we're going to go over this example of parse INI, which is something that is useful with regexes. Make sure we understand it, and then I'm going to go eat. So
Right? Yeah.
what we have here is parse INI. Let's look at this. Parse INI is, let's take a look at the INI file first. Here's an INI file. You'll notice this is actually a brilliant idea. It's probably one of the better ideas Microsoft has ever had. It's I think it's a Microsoft thing. You have key equals value. Very simple, right? You don't put spaces in an INI file. It's always key equals value, no spaces. At the above, you have a section. The section is with brackets. So you simply put the section in brackets and then key equals value. You will see this all the time when you're configuring Microsoft services, especially older ones, and even services on Windows. They all have .ini files. So you know, the root.ini and all that kind of crap is in this format. Comments have a semicolon and a space and then a comment next to it. It's a very, very easy configuration file to parse. And now we're going to see how we do it, right? So here's their method of parsing the configuration file with regexes. So you take the whole configuration file as a string, right? We create this thing called the result object. What we're doing is we're setting section equal to the result object, right? So we start off and we say section equals result. Now what we're going to do is we're going to populate section, and then we're going to flush it to the result. So actually it's vice versa. You're going to populate result and then flush it to section. So what we're doing is, if you remember, we have those different things in brackets. We're going to parse all that crap underneath the thing in brackets, and then we're going to flush it to a global object. Then when we get a new thing in brackets, we're going to parse all of the stuff underneath it, and then we're going to flush it to another object, right? So look here. We go up a little bit, right here. We're going to parse, this is one section here, right? So we're parsing key value, key value, key value. We're going to get an object. Then we're going to flush this object with this name into something else. So all of this stuff will become one JavaScript object, right? Let's take this whole thing here, and I'm going to paste it. I don't know why this thing. Click on this, deactivate editor. Okay, so here's the short example. Right. Okay, so here's an example. If we take a look at this example, there we go. There we go. So here's the parse INI thing. Here's the example they have. They have name equals whatever, address, and then city. What we're doing is we're parsing that into name equals, this is in the core of the object. And then we have another thing which is address, which is identified by this, which is the header, right? And then we have another object underneath it. So if we go back to the other file that we had, each one of these sections in that file, Larry and then all this stuff below it, this will all be in something Larry here and then all of the stuff below it. That's what we're trying to do. So here we have a section Larry, key value, key value, key value. Here we have a section address, key value, right? We're trying to move this Larry becomes a key with Larry, and then the value becomes an object representing all of the attributes of Larry. Does that make sense? Okay. Yes.
So, using regexes to do lightweight parsing is something that has a long history behind it. It's not a really bad idea, but just keep in mind that if you need to do some sort of heavy-duty parsing, there's actually real math and rules behind parsing, and a specific parser, you can beat regexes every time by writing something.
Without a doubt. Definitely. But we're not going to get into writing real actual parsers here. So we're just going to hack shit up with regexes. But yes, he's right.
It's called being clever.
Yeah, being clever. So look, what I want to show you though is I want to make sure we get this whole idea that the key here is address, right? The key here is address. The value is all of the attributes under address. That's how the INI file works. That's what you have to understand. Okay, so remember I told you that all of the real code is in the book here. In this case, it's not. So in this case, well, we're going to have to actually copy this into a string. So I'm going to take all of this stuff here. This is their INI file. And I'm going to copy it. I'm going to say let my INI equals this. And we're going to paste it. My INI. And you can see, yeah, there you go. It's all there. It's actually, what it's doing here is it's replacing the new lines with the new line character, right? So if I do console.log my INI, that's the one that you see in the page, right? So all that I've done is I've copied the SciI file into my JavaScript thing. And now what I've done is I've copied their parse.ini file in there too. So I can say parse.ini, my ini, and you can see this is what we want back. So I want to be sure we understand what we have and what we want back. This is what we have is right here. Larry, full name, type, website. This is what we want back. We want an object with Larry, full name, type, website. Underneath, Dave Orn, full name, type, output directory. Dave Orn, full name, type, output directory. The stuff on the top is still there. We're carrying it through. It just goes on the top of the object. This is what we want our parser to do. Now let's take a look at the parser so we can kind of reason about it and see what it's doing. So, we have this thing here, the section. Those sections were the things in brackets and all of the attributes underneath it. We create a section at the start, and now what we're going to do is we're going to split the lines. And as we split the lines, we're going to build up a section, right? So what we do is we say if the line matches a key value. That's an ugly way to write this. There's easier ways to do this. This is also how you could do it. You could say something like this. And we saw this earlier in class. Key value, right? And then you could just say key value. That would work just fine. I don't know why he didn't do it like that, but yes. So we're essentially saying if we have a key value, then we're going to put the key value on the section. Right? Otherwise, what we're going to do is we're going to test to see whether or not we have a header. We know that they're a header because we have the brackets. Right? Brackets normally mean something. What do brackets mean?
Class.
Character class. Right? Brackets mean character class. We're preceding them with a /, right? We're doing that so brackets don't mean character class because we just want to say the character bracket. In the header of the ini file, the characters were the header was inside of a bracket. So we're saying take everything inside of the brackets, right? And then what I want to do is I want to say here that we're going to start section into this, right? So essentially the section equals this result thing. So we have a different result object. Hold on one second. Line match equals. Why is this not the other way around? Why are we setting section equal to this and that?
Well, that's what we're accumulating.
Section is the accumulator.
Yeah, and it starts with the global section.
So where's result is here? Result
It's clever. That's why.
Is it adding each section?
You see, section starts as a result, and then it becomes a section. So section is also the global section, right, initially.
That is horrible. This is a horrible example. Don't ever write code like this, but that's right. So section here starts off as the global result, and then we actually return result. So when we take this here and we say match, right, we're looking for match.1, by the way, is his way of saying we want what's inside of this, right? Match.0 is going to be everything. We went through that multiple different times. The first element that match returns is everything that was matched. We don't want everything that was matched. We just want the things in between the captured parentheses. So we say match.1. So we actually record in the result object, which is up here, the global thing. We're recording a new object, right? So we're saying put into the result object for this header a new object. Then what we do is we say set that equal to section. And we start building that up. Every time we find a new key attribute, we put the new key values into it. And then what happens is we return the result at the end. So we have three cases here. We have the first case, we have an attribute key value pair. The second case, we have a header, right, which defines us a new place to start with the key value pairs. And then the third case is here. And in this case, we're actually just looking for comments, right? So we're saying here if we have a space, one or more of them, and then the semicolon. And that's a really weird way of showing comments, but that is how ini files do it. So if we go back up here, comments are preceded by semicolon. Each comment concerns an individual enemy. And we come down here, we're looking for one or more spaces, 0 more spaces rather, followed by a semicolon. And then this is the one thing we didn't cover in class, this dot, that means anything. We skipped over that part. That was the
Yeah, it was right on that part.
So the dot means anything. So the semicolon followed by anything. And then what we actually do is we just simply say that line is not valid.
just, well, it's inverted, testing that.
Ah, okay. We say if it's not a comment, that line is, this is all around really crappy code. I have no idea what it's thinking. Here's the better way to write that. If you have a comment, do this, else, you know, do that.
This is why you don't use regexes to replace proper parsing.
Well, and no, this also, this highlights a clean code theory that all conditions and if, like, you shouldn't have not in your variables, for example.
Yeah,
Because negatives are hard to read.
that's exactly right. Negatives are, that's the way that I would have written it right here, right? So now you have, if you have an attribute, if you have a header, if you have a comment, otherwise throw the arrow. Instead of the stupid way that it was written originally. But anyway, there's a lot of things that you can do better about this code. I just want to be sure we all understand it. The only thing that we didn't get to at this point was the dot, and the dot simply means any character. Doesn't matter what it is. New line, space, anything will work. Okay. That's it, we're done. Let's go and eat.
Let's go eat. That's it.
Can you remember being called Nirvana?
Yeah, I remember the final part.